So we're going to start with example number 1. We have a ball thrown right up in the air, and it's got a velocity of 40 meters per second. So our initial velocity, oops, I'm going to change that right now. Our initial velocity, VI, is 40 meters per second. Well, what else can we write down? We can write down that our acceleration is negative 9.81 meters per second squared. And before we write anything else down yet, we want to make an assumption. And actually this assumption is going to give us the answer to our second part here before it'll even give us our answer to our first part. And that is this. Let's look at a velocity versus time graph right here. So here's time and here's velocity. Now if we start with a certain positive velocity, we'll say, well, this is right there, that's 40 meters per second, we'll just say. As soon as we throw that up in the air, the acceleration of gravity is going to start affecting it. It's going to start pulling that velocity down slower and slower. And what we learned today was that at the maximum height of any object being thrown up in the air, the velocity equals 0. So at some point this thing's going to be slowed down, so it's got 0 positive velocity, and then it will get negative velocity as well. Well, to what degree does it get slowed down? It gets slowed down to the tune of negative 9.81 meters per second per second. So this slope right here is going to be, that's going to represent our acceleration, and that is our negative acceleration, negative 9.81. And so this means that if we start with a positive velocity, positive 40 meters per second, the acceleration of gravity will slow it down such that at some point it becomes 0 meters per second. That's at the very top of its trajectory right there, the max height. And then it will fall back down, and as it falls back down for the same amount of time that it was going up. And so when it hits the ground again, it's going to have a velocity of negative 40 meters per second. That should follow with a reason with you, or it should be reasonable to you that the same velocity going up is the same velocity coming down, except it's simply just negative. So we're going to write that in down here. Our final velocity equals negative 40 meters per second. It's the same magnitude, just a different direction because it's coming back down. So we're going to put this back up here at the top. Our final velocity, VF, is 40 meters per second. And do we know anything else about this? Well, we don't, but we're trying to find t. So our change in time is what we're trying to find out. We do have an equation that relates all of these. That's our final velocity equals initial velocity plus acceleration times time. And I think we wrote it as final velocity equals initial velocity minus gt, because after all, acceleration is of gravity is a negative. But you can write it either way, just as long as we make sure this second component right here is negative. It is made negative by the negative 9.81. So let's rearrange this now and solve for t. Well, what are we going to do? Well, we're going to take the VI and we're going to subtract it from both sides. So it's going to be VF minus initial velocity. And then what's left is the negative g multiplied by the t. So that's going to get divided on both sides. So that's going to come down to the bottom right there. So our time is going to equal our final velocity. What's that? That's, oops, I forgot my negative right there. Negative 40 meters per second, right? Equals negative 40 meters per second minus our initial, so it's minus an additional 40 meters per second divided by gravity, that is, or the negative value of gravity, so divided by a negative 9.81 meters per second squared. And that will give us a value in seconds. And that value is 8.2. 8.2 seconds. Now another way you could have done this was simply found the amount of time it takes to go from initial velocity up to the maximum height, which is the final velocity there would be 0 meters per second. And then you would simply double that because that's the time to go up. You double it and you get 8.2 seconds as your time to come back down. But either way, this works. So that's example number 1. Let's look at example number 2.